So today we're going to do some more work with proofs. We're going to look at proving segment relationships to start. We're going to begin with our segment addition. We have two postulates related to that. The first one is called the ruler postulate, and it says that the points on any line or line segment can be put into a one-to-one correspondence with real numbers. Then we also have the segment addition postulate, which says if A, B, and C are collinear, so all on the same line, then point B is between A and C if and only if AB plus BC is equal to AC. So this is a biconditional statement, which means that if AB plus BC is equal to AC, we can also conclude that point B is between A and C and that those points are collinear. All right, we're going to jump down here, and we're not doing all the proofs in this section. We're just going to do selected ones. So we'll do the first one and skip the second one. It says complete each proof. Number one, given that BC is equal to DE. So BC right here is equal to DE. Prove that AB plus DE would equal AC. So here they've set up the proof for us, and we need to fill in the missing statements and reasons. The first statement that they give us is BC equals DE. That was a given statement, so our reason for knowing that is because it is given in the problem as a true statement. Next it says seg add post. That's abbreviated version of segment addition postulate, which is what we just talked about right here. The segment addition postulate allows us to say AB plus BC is equal to AC. So on this segment, AB plus BC would equal AC. So the segment addition postulate would tell us AB plus BC equals AC. Now, the last problem, the last statement says AB plus DE, which is what we're trying to prove, is equal to AC. So they have taken BC out and they have replaced it with DE. That's a legal move because we've already established that they are equal to each other. So we're taking one thing out and replacing it with something else that it is equal to. That is called doing a substitution. And that proof is now finished. Yay, we did one. Okay, let's go on to the back. The next page says reflexive property means that a segment AB is congruent to itself, a segment AB. Reflexive kind of makes me think of the word reflection, like you have your reflection in the mirror, which is the same as yourself. So the reflexive property tells you that one segment is congruent to itself. Seems kind of obvious, but we do have a property for that in geometry. The next property is called the symmetric property, and it says if segment AB is congruent to segment CD, then segment CD is congruent to segment AB. All they did was reverse which one came first and which one came second in the congruent statement. So that's called symmetric property. It's like you flipped it around, okay? The transitive property says if segment AB is congruent to segment CD and segment CD is congruent to segment EF, then segment AB must be congruent to segment EF. Okay, so AB is the same as CD, CD is the same as EF. We can connect AB is the same as EF. Now, down here at the bottom, we have a proof to work through. We're going to skip these first three statements and work on our proof. It says, given that segment PR, which is from here to here, is congruent to segment QS. So from here to here. Those are congruent. Prove that segment PQ is congruent to segment RS. So that's what we're trying to prove. our first statement in the proof is that segment PR is congruent to segment QS. Okay, that's given. So our reason for saying that is that it is given. Next, it says PR, which means the length of the segment from point P to point R, is equal to QS, the length of the segment from point Q to point S. Okay, so those are equal lengths because they were congruent segments. So that is by the definition of congruent. This can sometimes be a lot of writing when we're doing a proof. So if you want to abbreviate DEF for definition or DEF apostrophe N for definition of, and then use the congruent symbol instead of the word, that is fine. All right, next it says PQ plus QR is equal to PR. So that is your segment addition postulate that we just learned today. And you can abbreviate that seg add post for short if you would like. Now, the next statement has another segment addition postulate. So what other segment addition could we do here that would make sense for this problem? We did PQ plus QR is PR. Similarly, we could do QR plus RS is equal to QS. So let's do that. QR plus RS equals QS. Now, they're not numbered, they're lettered, sorry. Part E. PQ plus QR is equal to QR plus RS. How do we get that? Well, if you notice, PR is equal to this, and QS is equal to this. We also know that PR is equal to QS. So if PR is this, we could take the PR out and replace it with PQ plus QR. And if QR plus RS is equal to QS, we can take out this QS and replace it with this. That's called doing a substitution. I am a math teacher. If I can't come to work, they're going to replace me with something equal, which would be a substitute teacher to handle things while I'm out. So doing a substitution is when you take one thing out and replace it with something that it is equal to. Now, the next statement is missing, but it says we're going to use the subtraction property from algebra, which the subtraction property says that you can subtract any number from both sides of the equation and the equation will maintain equality. Notice in this equation, there's a QR on both sides. So if I subtract QR on both sides, I get PQ equals RS by the subtraction property. And then the last statement is always going to be whatever it is you're trying to prove. So we can say segment PQ is congruent to segment RS by the definition of congruence of segments. If two segments have the same length, then that means those segments are congruent. All right. Next, we're going to go on and look at proving angle relationships. So that was about segments. Now we're going to do some work with angles. We have a protractor postulate which says, given any angle, the measure can be put into one-to-one correspondence with real numbers between 0 and 180. So that's just allowing us to set up a measurement system of angles from 0 to 180 degrees for a straight line. The angle addition postulate follows, which is pretty close to the segment addition postulate. And it says R is in the interior of angle PQS if and only if the measure of angle PQR plus the measure of angle RQS is equal to the measure of angle PQS. Next, we have the supplement theorem. If two angles form a linear pair, then they are supplementary angles. Notice these angles in the picture are a linear pair. They share a side, they form a straight line with their non-shared sides. The complement theorem says if the non-common sides of two adjacent angles form a right angle, then the angles are complementary angles. So here, angle 3 and angle 4 are complementary. They add up to not to 180, excuse me. They add up to 90 degrees. The little right angle box indicates we're looking at a right angle. So they are complementary. Now we're going to go down and look at the problems at the bottom. I want to make a note here that the pictures are not drawn to scale. And you're going to need to watch for that in geometry. Sometimes the pictures are not the size of the angles that you would expect for a problem, and so you just have to base your work off of the given information. We're going to do number 1 and we're going to do number 3. We're going to skip number 2. It says find the measure of each numbered angle and name the theorem that justifies your work. So on number 1, we're supposed to find the measure of angle 7 and the measure of angle 8. Notice these two angles form a linear pair. So we're going to use the supplement theorem. If two angles form a linear pair, then they are supplementary angles. So that means they add up to 180. So we're going to say the measure of angle 7 is 5x plus 5. So 5x, oops, let me get where you can see my work. 5x plus 5 plus angle 8, which is x minus 5, has to equal 180. Okay? This is angle 7, this is angle 8. 5x plus 5 plus x minus 5 has to equal 180. And now we'll do the algebra to solve the equation. 5x plus 1x is equal to 6x. 5 minus 5 is 0, so these add up to nothing. And then that equals 180. Now to get the x by itself, we divide by 6 on both sides. So x is equal to 30. 180 divided by 6 is 30. But that's not the answer to the problem because they said to find the measure of each numbered angle. So we have to substitute that back in for x to solve for the angle measured. 5 times 30 plus 5. So that's 150 plus 5 more is 155 degrees for angle 7. And angle 8 is going to be 30 minus 5, which is 25 degrees for the measure of angle 8. All right, moving on to number 3. We have to find the measure of 3 angles here, 11, 12, and 13. They have given us some algebra information about 2 of them, angle 11 and angle 12. Notice these are vertical angles. That means they must be congruent. So I'm going to set them equal to each other. Oh no, they didn't give us 12. Sorry, they gave us 11 and 13. 11 and 13 form a linear pair. So they add up to 180. If they had given us 11 and 12, we would have set them equal to each other. But since they gave us 11 and 13, they make a straight line. So we will put that they add up to 180. 11x plus 10x plus 12 equals 180. 11x plus 10x makes 21x plus 12 equals 180. We're going to subtract 12 on both sides. So 21x is equal to 168. Then we will divide by 21 on both sides. So x equals 8. but that is not the answer to the problem because we have to substitute 8 back in for x. 11 times 8 is 88 degrees for the measure of angle 11. 10 times 8 is 80 plus 12 more makes 92 for the measure of angle 13. Now, you can probably see why I cautioned you that the pictures are not drawn to scale, because in my picture it appears that the measure of angle 11 would be obtuse, greater than 90, it's only 88, and the measure of angle 13 would be acute, less than 90, but it is greater than 90. So that's why I warned you that the pictures are not drawn to scale, but we have correctly solved this problem. Okay. Now we're going to talk about congruent and right angles, okay? There are several theorems here that we're going to take a look at, and then we will use to solve a couple, or just one more. We're just going to do one more proof. The first one is the congruent supplements theorem. Angles supplement, which means like supplementary angles, to the same angle or congruent angles are congruent. So if two angles are supplementary with the same angle, then they have to be congruent to each other. Congruent complements theorem works very much the same way, except for this time we're going to say angles complement to the same angle or to congruent angles are congruent. So if two angles add up to 90 with the same angle, then that same angle would have to be congruent on both. Vertical angles theorem. If two angles are vertical angles, then they are congruent. That's where you have the x. Congruent angles opposite from each other. Theorem 2.9. Perpendicular lines intersect to form 4 right angles. If you have two lines that intersect perpendicularly, then all 4 angles formed are 90s. All right angles are congruent. They're all equal to 90, so they have to be the same size and the same shape. Perpendicular lines form congruent adjacent angles. So right here, all these angles are congruent and they are adjacent, which means that they are side by side. Theorem 2.12. If two angles are congruent and supplementary, then each angle is a right angle. So if you know that they add up to 180 and they're the same as each other, they have to be 90 each. 90 plus 90 equals 180. And if two congruent angles form a linear pair, then they are right angles. Again, because 90 plus 90 would equal the 180, and linear pairs add up to 180. 90 plus 90 is 180. Okay, we're going to go down here and do number 1. We're going to skip number 2. It says complete each proof. Given that segment AB is perpendicular to segment BC, and angle 1 and angle 3 are complementary, so 1 plus 3 is 90. Prove that angle 2 is congruent to angle 3. So we've got most of the proof filled out. We're just going to be filling in the blanks. The first statement is that segment AB is perpendicular to segment BC. The reason we can say that is because it is given right here in the problem. That's a given piece of information. Now, you would think that they would go next to the other given statement, which is that angle 1 and angle 3 are complementary, but they don't have given for the next reason. They have given down here on statement G. I wouldn't have sequenced them in that order, but they have their reasons. But I'm going to jump down here to where this other given statement is and go ahead and fill in angle 1 and angle 3 are complementary. And I'm going to abbreviate it just the way they have it abbreviated above on statement F. Now, the next thing that they have on statement B is a blank where it says the definition of perpendicular. So if something is perpendicular, then that means that it meets at a 90-degree angle. So do you see an angle that would have to be a right angle if segment AB is perpendicular to segment BC? How about angle ABC is a right angle? Then they've got this whole next one filled in for us. The measure of angle ABC is 90 degrees. That's the definition of right angle. And then it says the measure of angle ABC is equal to the measure of angle 1 plus the measure of angle 2. Well, that's that angle addition postulate that we just learned today. These two smaller angles add up to the larger angle that contains them both. Next, they have a filled-in statement that 90 is equal to the measure of angle 1 plus the measure of angle 2. That's because 90 equals the measure of angle ABC, and the measure of angle 1 plus the measure of angle 2 also equals the measure of angle ABC. So you can do a substitution and just say 90 goes where the measure of angle ABC is. Now, angle 1 and angle 2 are complementary. That's going to be by the complement theorem. Remember, two angles that add up to 90 degrees are complementary. I would also be fine if you wrote definition of complementary because that is one of our vocabulary words. And next, we have the weird given statement that was thrown in later in the proof. Angle 1 and angle 3 are complementary. That was given in the problem. Now, if angle 1 and angle 2 are complementary, and angle 1 and angle 3 are complementary, then angle 2 must be congruent to angle 3, which is what we're trying to prove. And the reason for that is a theorem that we just learned above on this page. That is the congruent complements theorem, which said angles complement to the same angle or to congruent angles are congruent. So that is now finished, okay? So in your assignment today, you're going to have to show some knowledge of the different theorems and definitions that we have learned so far, maybe even a couple of postulates. And you're going to be working on writing out proofs, filling in blanks on proofs to show a logical argument, how you start with some given information and use the properties that you've learned in geometry to prove something else from it. I wish you all the best of luck with this. If you need help, please do not hesitate to reach out and let me know, and have a wonderful day. Bye.